Hey guys, welcome to another Squidnet video. In this video, I'm going to be talking about the overall architecture of the Squidnet Render Farm Manager. As you can see from the diagram here, we'll be covering the different components involved within the render farm. At the center of the diagram is the Squidnet Master Controller, which is the component that controls the entire workflow. It's responsible for managing all the input and output of content to and from the farm, as well as job distribution of the rendered content by taking the user's project contents and distributing that content to the available render farm nodes. Let's start by discussing this diagram in more detail. I've divided it into different network components: wide area network and local area network. For the local area network, you can have workstations running Linux, Mac OS, or Windows. Within those workstations, you can use submitting applications for Squidnet. In this example, we have 3 different submitting interfaces, all desktop tools. There's a cloud user interface for submitting jobs in batch mode or manually inputting content into forms, filling out fields like start frame and end frame, and submitting the job to the farm. The Streamer is a system tray application with an associated plugin that's integrated into the menu systems of the rendering applications such as Maya, Blender, and Cinema 4D. There's also a command line interface called CCL, which is useful for scripting and submitting multiple jobs at once. As shown, these workstations are connected directly to the Squidnet Master Controller. On the wide area network, you have a similar configuration. Remote workstations, which could be offsite, can submit jobs to the farm using the same set of tools: the cloud user interface, the streamer, and the CCL command line interface. These communicate to your router through an open port, which we'll cover in a subsequent video, with all communications secured over OpenSSL. The render farm content is stored on local storage devices. In this example, we have project storage, archive storage, and database backup storage. Although these can be consolidated into a single network storage unit, we've separated them here for clarity. Project storage holds user project folders, related assets, and any texture maps needed for rendering. Archive storage retains rendered content for a default period of 1 week. The backup storage device handles nightly backups of the entire system's workflow, metadata, user content, and render credit information. At the bottom of the diagram, you can see the Squidnet render farm nodes, which are the main work engines of the farm. These render nodes take content from the master controller and render it to a specific project folder on the storage device. All render nodes must have access to the project storage content, as all information is read from and written to the local network's project storage folders. Additionally, Squidnet keeps track of the entire workflow for hundreds of jobs via a SQL database. This database can be accessed externally through either a web server or a Python interface. The SQL database is embedded within the Squidnet Master Controller, supporting languages like JavaScript, PHP, Python, JSON, C++, and others. So this has been a high-level overview of the Squidnet render farm architecture. In the next video, we'll set up a complete render farm from scratch using Windows, Linux, and Mac OS workstations. See you in the next video.